Physicists have a natural tendency for curiosity, as I'm sure you've been aware for some time now. But the curiosity of this young student far exceeds the regular standards of his peers. Here he is, alone, doing homework. Suddenly, a problem appears that catches him completely off guard. A scientist succeeds in stopping the moon in orbit, says the problem, and it accelerates towards Earth due to gravity. How much energy would the resulting collision release? Well, thought the student, if the moon suddenly came crashing towards Earth, doing this calculation would certainly be the least of our worries. The explosion would be one the likes of which we have never seen. But is it really that simple? How did the scientists stop the moon? Could this really be done? What would happen after the collision? Has anything like this happened before? It seems as if there was so much that the question was hiding, and the students suddenly needed to know more. The moon orbits Earth in a near-circular orbit, and, in spite of its appearance, is very far away. So far, that if the student's head were the Earth, the moon would be a little smaller than his fist, and over by that post. It travels about 2 million kilometers around the Earth every month, and because of its rotation, we always see the same side of it. Any two objects with mass, like this piece of paper and the Earth, attract each other, which explains why when the paper is dropped, it falls. Now the moon is about 1/80th the mass of the Earth, but it's still billions and billions of pounds. We know by Newton's law of universal gravitation that the force between the moon and the Earth is in the realm of 10 to the 20th newtons. The force is about the same as the weight of 20 billion fully loaded SUVs. If that force is so strong, why doesn't the moon fall to Earth then? Well, the moon travels about 2 million kilometers in about 27 or 28 days, which is incredibly fast. At any time, the moon has a speed of about 1 kilometer per second. The moon actually is falling right now due to its immense gravity, but because of its speed, it actually falls around the Earth, never hitting it. So how does our scientist stop the moon? When potatoes are thrown at the student, he stops them by pushing at them in the opposite direction. All our scientist has to do is push at the moon strongly enough in the opposite direction. There are two ways to do that. He can either decelerate the moon slowly, or he can impact the moon with something very fast. If we want to impact the moon with something and stop it, we must need an object with as much momentum as the moon has to hit it in the opposite direction. At its speed of about 1 kilometer per second, the moon has 7.5 times 10 to the 25 kilogram meters per second of momentum, about the same as one of those fully loaded SUVs traveling down the highway, times about 2.5 billion trillion. Now could we stop that? The heaviest craft launched into space was the Saturn V, which weighed 2.8 million kilos. But it traveled at about 3 kilometers per second at the fastest, so had a total momentum about 1/300 billionth of that needed to stop the moon. The fastest spacecraft is the Voyager 1, which is traveling at about 17 kilometers per second, approaching interstellar space. But with the weight of about the average car, it has less momentum than the Saturn V did. We don't have to crash something into the moon to stop it. What if we tried slowing it down steadily over time? Well, the Saturn V also had the most powerful thrust of any spacecraft, with a top force of 34 million newtons, which is about the weight of 3,500 of those fully loaded SUVs we're so fond of. As strong as that force may be, if that force were directly exerted on something as massive and as fast as the moon, it would come to a halt after 70 billion years, about 5 times the age of the known universe. Stopping the moon in orbit is clearly impossible. So what, thinks the student? Even if it can't be stopped, what would it be like? Well, if the moon suddenly stopped in orbit, it would accelerate very slowly towards the Earth. The force of gravity between any two objects is inversely proportional to the distance between their centers, so the further away an object is from the Earth, the weaker gravity acts on it, and the moon is very far away. It's so far away that although both the Earth and the moon are immensely heavy, the moon's initial acceleration towards the Earth would be about 3 millimeters per second per second. Every second, it would go 3 millimeters per second faster, very slowly gaining speed. As the moon approaches the Earth, the force on it would become greater, and its acceleration even faster. Right before the moon strikes the Earth, it would have a velocity of 10 kilometers per second.